Hello everybody, so today I will explain this question. Maximum XOR of two numbers in an array. So I solved this question yesterday and explained this question with a suffix hash set. So this is my second video on this question, and today I will solve this question with Bitwise Trie. Okay, so given an integer array nums returns the maximum result of nums I XOR nums j, where I and j are in between 0 and n. So I and j is a valid index. Okay, so let me clarify my understanding of this question first. So in this question, I will be given the integer array nums, and I will return maximum result, which should be a number, obviously. Okay, so for example, if I'm given something like, let's say 10 and 8 and 13. Let's think of this case. So if I'm given something like this, so let me convert each number into bit array. So let's write it in a least significant digit first. So it looks like this. So 10 should be 0, 1, 0, 1, and 8 should be, let me change this to 7. So 7 is 1, 1, 1, 0, and 13. This should be 1, 0, 1, 1. Yeah, this one. Okay, so this is the bit array for each number. And I try to find the maximum pair, the best pair which maximizes the XOR value. And actually, I can choose the same number twice, like 10 and 10. But in that case, obviously, the XOR becomes 0. I think it isn't a good choice, unless there is only one element in the given array. So that being said, let's think how I can maximize this. So let's say I take 10 and 7. In that case, the XOR looks like this. So this is actually 1, 4, 8, which is 13. And let's think of 10 and 13. So in this case, the XOR bit array is 1110. So it should be 7. And let's say I take 7 and 13. In that case, so it looks like 0101. So it's now M. So in the end, I return 13. Right? Yep. Okay. So in this way, I can find the maximum XOR of any pair in the numbers. So that being said, yesterday I talked that, this is a kind of brute force approach, which takes O of n squared time complexity. Yeah, because I have to check every possible pair and calculate the XOR value. Yeah, so it takes O of n squared times L. So L is the length of the bit array. So bit array can, as long as, the biggest number in the array decides the length of the bit array. Because for example, if I have a very big number here, in that case, I should have something like this, blah, 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 blah. In that case, every time I have to do the operation of XOR for this number, I have to, scan this digit. So this L length of the bit array is decided by the largest number in the given array. Yeah. So that's the brute force approach. I mean, the time complexity of the brute force approach. But let me, optimize this. And yesterday I talked about the, um, hash set of suffix. Yeah. With this approach, the time complexity was n times L squared. But today I will explain another approach. Okay. So that being said, oh wait. Okay, so before I introduce the bitwise trie approach in this video, I want you to notice something. So let me tell you what it is. So let's think of these three numbers. Yeah. This is 4, this is 0, and this is 7. Yeah. So my question is, for this guy, which one is a better partner to maximize XOR? Let's think. So this guy, for this guy, most significant digit are different, 1 and 0. I get 1 here. But two less significant digits are the same. So I cannot any value from these two digits. So this means that it is 001, which is 4. Yeah. And for this guy, if I think of this number as the partner of this guy, so for the most significant digit, they're the same. So I cannot get any value. But for less significant two digit, they are different. So I get 1, 1. So it looks like this, and I get 3. So the interesting thing here is that for this guy who missed XO1 as the most significant digit, he couldn't compensate the loss with smaller values, smaller digit. So on the other hand, for this guy could get XO1 as the highest digit and missed XO1 at less significant digit, all of them. But even with this guy overbeats this guy. So here, the observation, or I should say learning, is that I should get XOR1 at the most significant digit at any cost of missing XOR1 at less significant digits. Sorry. So this is something I can learn from here. So let's think of the bitwise trie approach with this in your mind. Okay, so this in my mind, I will introduce the bitwise trie operation. So yeah, I use this example, and let's say I have this guy first. So for this guy, which one is the better partner? Obviously, it is 0 here because it matches 1 here. I mean, it can create XOR 1 with this. So I've decided to choose this one. And next, because this is the only option, I keep going 1. Yes, and I get XOR 1 here. But here, this 1 and 1, XOR is now 0. But I have to take this guy 7. Because if I choose 13, yeah, for this position, XOR becomes 1, but I missed this XOR. No, sorry, I missed this XOR. So as I said, I should prioritize the XOR one of the higher digit. So I shouldn't choose this one. Yeah. So this in your mind, if I write something like the trie, it looks very interesting. So let me write it. Okay, so I stopped the video and wrote the trie. So here, this 10 is represented as 1010. This guy. So this one is 10. So please keep in mind that here, numbers are sorted in real significant digit first, but in my trie, higher one should be most significant digit. So I, if I track the path, it goes backward in the bit array. So 1010, this one is 10, 0111, so this one is 7. Okay. And for this one, 13 is 1101. This one. Okay. So now let's think. I think of the pair of 7. No, 10. I mean, best body. So when I think of this 10, so ideally, the answer is ideally, because this 10 is 0101, it's 1010. So 1010. So let's try to find it in the trie. So I start from the root, and as I said, I track backward. So I firstly try to find 0. Yes, I could find it, but definitely I have to go to this direction. I should never choose 1 first at this digit, at this position, because this is the most significant digit now, and I shouldn't compromise on this. I go to here. Then I write to 1. Yes, so I find 1. So definitely I should go here. And actually, this is only a path I can take. And then I want 0, but actually 0 doesn't exist. 0, 1, 0 something. Such number doesn't exist. So I have to choose 1 and come here. So because this is the only option I can take. So next, I want 1, and yes, I can find 1. So I go to this path. Yeah. So in this way, I could find in the end, I found 0111. Yep, which is 7. Yeah, hope you understand what I'm doing here. So something I can say is, yeah, let's think of next example. 0111 or 1107. Best body, or it's just ideal body is 0001. So I try to find it backward. I find 1, yes, and I find 0, yes. Like I'm here. And I want 0, but I can't find it. So I can't find 0, so I have to go to this path. And then the last digit should be 0, and I can find it, so I go to this. If this is, for example, 1, because there isn't any option, I have to go this way. But let's say this guy has child 0 and child 1. In that way, even though I compromise here to come 1, For the least digit, I want 0, so I should go this guy, this direction. So that's what I can do here. So basically, let me sort out what I did. So build trie first. So this is called bitwise trie because each node has the child 0 or 1. So firstly, I build the bitwise trie, and for each num, wait a minute. So for each num, try think of ideal body. Try to follow that path. But if impossible, compromise. And I do this until reach the leaf node. So this means that I've decided the body, actual body. Then calculate XOR of num and that actual body. Yeah. And in the end, what I do is I returns the max of this. Returns the max of this in the end. Oh, sorry. Okay, so this is what I will do from now. Okay, so now it implements this logic. So let me get started with implementing the trie. So for implementing the trie, I need the node class. So I need the digit for each node. And also I need the children, which is pointing to the child nodes. Yeah, this is it. And actually, I want to know which number each of, node signifies. For example, for this node, this signifies 110. So it should be the number, because this is most significant digit first, 011, which is 3. I want that kind of number. Like this. Okay, so this is what I want. And with this, I implement the trie class. So this is a pseudo node. Okay, and let's register each number. Yeah, oh, sorry. Let's pass bit array. So this bit array should be in real significant digit first. So, because, yeah, I actually already implemented this solution before this video, so I know this is more convenient. So you will find it later. So, that being said, as I said, when I register the number to this bitwise trie, I have to go from most significant digit first. Like for this number, I should start from 1, like backward, and create the node like 1010. So I have to go backward. I can say So this is the current digit. And for num, because I'd like to put the num in each node, I have to keep track of the current num also. So let's start with current num 0. So I find D. So this num should be like this. Yeah. So for example, if I have already this number, like 10, I'd like to append this reassignificant digit 1. So what I should do is shift this 10 one bit larger direction, and then append this 1. So this is what I'm doing here. So 10. Yeah. Let's think of now for reassignificant digit first. In this case, I shift this 10 and then add 1 here. So what I'm doing here. Okay. So this is how I can update num. And here I have to create the node. So if, and also I need the pointer to the current node. So I move this current pointer from root to, downward. So I can say if D doesn't exist in the current children, I create the node first. In this way. Then I move the current pointer. Yep. So I think this is how I can create the trie. Yeah, looks good. So with this trie, I will implement this logic. Okay, so the first thing I should do is to create this bit array. So here, let's say if I'm given 10, let me change the set. No, let's change to 5. In this case, I will return 1, 0, 1. It's not a good example, I think. Let's think of 4. If I'm given 4, I return this, which means that least significant digit head. Okay. So, yep, I will implement this later. That being said, so I create the list of bit arrays here. Like this. And something I have to do is I have to align the length of the bit array. If it looks like this, currently this 0 doesn't exist. It looks like this. So according to the maximum length of the bit array, I have to fill zeros in the tail of each list. So wait, maybe I can use the max function in this way. Okay, I've just asked ChatGPT and he said I can write in this way. In this way, I can find max bit array ranks. So from here, I take a look at each array. And if this ranks is not enough, it shortens the max bit array ranks, I have to append 0 to the tail. Okay, so this is it. So now I could create the bit arrays. So let me print it out. Oh, no, I haven't implemented this. So I believe this works and I continue. So from here, I will do this. Let me copy paste this. Yeah. Okay. So for each num in nums, first thing I do is think of the ideal body. Oh, this is something important, interesting. So let's say I have 101. Ideal body is what 010. So actually there is a formula. So let's say I'd like to make XOR of something to be 0. In this case, this is XOR. Wait. Yeah, let's say this. I have X and I'd like to know Y, and I'd like to create Z with that Y. So in that case, this Y can be written as X XOR Z. So for example, if I'd like to create 101, I mean, if I have 101 and I'd like to create 111, I can calculate this something with this way. In this way, I can calculate that it should be 0, 1, 0. Yeah. And actually, this is true. If I take 101 and 010, I can get 111. So this is something I can use. So this is a quite basic formula of XOR operations. So you can search on the internet to find this. Okay. So ideal body should be, because I'd like to 111. But wait a minute. Yeah. So, okay, so let's think of this in a different approach. Yeah. So in this case, I want 111. Let's think of this, right? Or I can say, I want this and create 111. So I just have to, flip each digit, like 1 to 0, 0 to 1, and 1 to 0. And I get 010. And if I take XOR of 101 and 010, I get 111. So in this case, because I would like to create 101, I just have to flip each digit. So I can do it in this way. So I take a look at ice index in the num array. The current num is like this. So that being said, ideal body should be bit arrays index I. Let me say bit array. This is a current bit array. So ideal array should be this, and I flip. So if I have 0, I want 1. If I have 1, I want 0, so I can calculate in this way. So this is the ideal array. So my task is try to, you know, track, I mean, go down from the root of the trie to follow this path as much as possible. But if I can't, I compromise in some decisions and I reach the bottom, the reef. And then I should return that number because this is the actual best body. So I do it. So first that, I implement some method here. Best effort pass num. And I pass the bit array here. Again, this is in LSD head. Okay. And I return the num. Okay, so here, I need to try in the first place. So I register each number to try. And here, I guess the actual best body. Best possible. Let me change it to body. Okay, so I get try and best effort pass num. And then I pass ideal body. This should be array, but I should get num here. Let's say just body num. Then here, I calculate the XOR with nums I and actual best possible body in this way. So this is the local XOR max, right? But what I want to return is the global XOR max. So I update this global XOR max with local XOR max. And return this in the end. Okay. So I take a look at each number and I convert it. This is the bit array of the number. And ideally, the body array should be like this. So I flip each digit in this bit array. For example, if I have 101, I want 010. And in the try, I try to go down the try from root node to the reef with this pass. And then I get the body num. This is the actual best effort body, best body. So I get the XOR with this nums I and body num. And I update the global XOR max with that, and I return it in the end. Okay, looks good. So my my remaining tasks are to implement this guy and also this guy. Okay, so let me get started with them. So I start with this one, which is more important. So again, I have to track in a backward way from this bit array because I have to start from highest digit first in this trie structure. So and I start from the root node, actually pseudo root node. So if Oh, sorry. So the digit I want to go is this one. And if this is, I mean, inside of the current children, I can go there. So otherwise, I have to go 1 minus d. Because if I want to 1, but I can't find 1, I have to go 0 direction. Yep. And the same for the case when d is 0. So let me write it here. Ideal d is this, and actual d is, if this is the case, I go to d, but otherwise, I go to 1 minus d. Okay. So I go to this direction. Good. And I keep going, and in the end, I return the current.num. So yeah, we store the current number onto the try node. I can just return it when I'm at the ref node. Okay, so now the remaining one is this one, 2-bit array method. This is quite simple. So and I return read. Okay, so this is it. For example, if this is 4, I get 0 first, and the num becomes 2, and I get 0 again, and num becomes 1, and then 1 divided, modulo of 1 divided by 2 is 1, so 1 is appended, and this num becomes 0, and that's the end of the while loop, so I return 0, 0, 1. Good. Okay, so yep, now I'm done with the implementation, so let me submit. What's the problem with this? Num instance of intent solution. Num. Ah, it should be self and num. Okay. So, I see. This is bit array. Okay. So this is typo. Max bit array ranks. Oh. Seems like this is the list. Let me print out. So I get this guy. The ranks looks like this. Wait, max bit array ranks. Seems like completely broken. So bit arrays, this is okay. And max bit array ranks. Okay, I searched something and I find that I use this max method in the wrong way. The max method actually returns the element of the bit arrays. Yeah. So actually, when firstly, this max array applies this lambda function to each element and compares them and finds the maximum one. But it doesn't apply this lambda function when returns the kind of max element. This actually returns the array, bit array, which has the max length in this bit arrays. So what I have to do is I have to do this. Sorry. Okay. Good, seems like so far it's fine. Let me quickly check. Bit arrays looks good in the end. Yep, looks good. And the problem is this one. I see, I forgot to pass num. And this is typo. And when I register some number, self here, object of type int has no ranks. Bit array, this is added here. Okay, I see. I didn't apply. I have to apply this to bit array method so that I can pass the bit array. Cannot access regular variable num. Yep, so this should be num's I. Wait. So, sorry. I start with num is equal to num's I and update this num in the pass. No, sorry. Wait a minute. I should start from 0. And every time I go down the root, I go down the node, and it should be here. Every time I go down the node, I have to update the current num. Okay. Node object does not represent children. So type again. Sorry. Sorry, if this D isn't in the children, I create the node. And there should be ID of D. Okay. Int and non-type. Body num is non-type. Did I return something? Oh, I didn't. Sorry, I write scalar in my daily job. I forgot to return here. Let me see. So let me print out what is ID of D here. Oh. So when I start 00111, yeah, 11100 good, 10101 good. But in the end, I couldn't find. I think I couldn't find this one, right? So since like I have to print out this where is it? Bit array and believes that trie is created correctly. And let's see what's happening here. Okay, so when I try to start from 101, okay, so the problem is if I can't find ideal D, I assume that this actual D actually exists as the current children's. So I assume this actually. It seems like this is not correct. I assume this because every path has a children. I mean, there is no path which ends at somewhere like this. I go until here and then it stops. It doesn't happen. So that's why if the ideal D doesn't exist, then actual D actually exists as a child. But this is not true actually. So this means that there are two cases. This current is leaf, but I keep going down, or this current doesn't have any child. Sorry, in either way, this current should not have any child. Yeah, true. But I'm trying to keep going. Where is it? Hmm. Maybe I registered something which is too short in the bit array. Ah, seems true. Wait, I think I, appended 0 here. This is not true, maybe? I see. So I found the reason why. So here, I register the bit array which is converted from now. This doesn't have filling zeros in the tail. So I have to, pass this one. Like this. Okay. Good, now accepted. So let me remove the print statement. And I submit. Okay, so memory limit exceeded. So this suggests that the logic is correct, implementation is correct, but not efficient. So let me optimize this. So in this implementation, the bottleneck is actually the number of nodes. So this kind of very, very big trie, there are so many nodes in the trie. And this data structure is somewhat big. So I actually tried this before taking this video and confirms that if I don't use this data structure, but instead if I use the hash map, this approach is accepted. So in big O notation wise, the space complexity doesn't change. But I mean, if I don't use this data structure, this class is accepted. So let me tell you how I can do it. So here I have the node in each trie, as the node in the trie. But actually I can optimize this to in this way. So instead of this, I just have the hash map like this. So I have the hash map, and if 1 has the child, it looks like this. And if 0 has the child 2, it has the hash map. And this hash map is actually pointing to the child node. So again, I want to say this. I mean, I replaced the I node with the hash map. So this is pointing to this, and 1 is pointing to actually pointing to the child, which is at here. So that's what I will do from now. So I uncomment this node class, and here I don't do this. Instead, I just put the empty hash map here, which is a kind of pseudo node. And when I register, so instead of this, the parent itself is the hash map. So I can do this in this way. And instead of this, I have the hash map. And I mean, if there is a hash map, even if it is empty, it suggests that there is a node. So I do it in this way. And here I do it like this. And here again, I don't need .children. I just take a look at the hash map and check if either D exists in the hash map. Okay. And here, yeah, I think this is it. But the problem here is now current is always pointing to the hash map. So I cannot get this current num. This is a problem. So how can I do it? So instead of doing this, and also here, when I register, I cannot register this num. Wait a minute. Num and current now. Oh, wait. This is actually not used. Sorry. So I kept track of the num when I go through the nodes, but I actually cannot register this num to the node. Wait, where did I do that? I'm a bit confused. Because in the end, I get current.num. Wait, did I delete something? Yeah. I deleted this guy. So yeah, I remember that. So before, I stored the current num, in the node object and use it, but it's not possible anymore. So this isn't possible. I deleted, but somehow I have to get this num here. So what I can do is when I go through the nodes, I calculate the current num here instead of storing it in the node. So I do something I did similar to here before. So here, when I move the current pointer, also I do update the current num in this way. And in the end, I return this current num. Okay. So let me submit my code again. Accepted. My fingers crossed. Okay, accepted. So I could make this solution optimized in terms of the memory. So now it's accepted. Great. Okay, so now we'll talk about the complexity analysis. So for the time complexity, the first thing I did is creating the bit array for each number. It takes n time, and I had to register each number which has the maximum ranks L to the trie. So it takes NL time again to register all of the bit arrays to the trie. Then, so, sorry, I started from each number. For each number, I decide the best path. For each number, I decide the best path and try to go through it. Sometimes I compromise, but in the end, I move L steps to reach the reef. And then I guess the actual body and I calculate the XOR, which takes L times. So in the end, it takes this much. So the time complexity should be O of NL. For space complexity, I created the trie, which takes NL. This is a case when each bit array is unique and it never shares a suffix, or I should say it's a prefix in the tree. So first numbers goes 0, 1, 1, 1, 0, 0, 0, 0. Next goes 1, 1, 1, 1. And next goes 0, 1, but then 0, 0, 0. Even though this shares one node, I try to, make the bit array doesn't duplicate, or I should say, I try to, the pair of, bit arrays never share the same node as much as possible. So in that idea, in worst case, the trie takes NL space complexity, and also bit arrays too. So bit arrays takes NL, trie takes up to NL. And aside from that, I don't need any data structure, which is non-constant. Yep. So in total, it's O of NL. Okay, so this is it. So this is the complexity of this solution. Okay, so now let me quickly wrap up. So today I solved the question, maximum XOR of two numbers in an array. So this is my second video on this question. And yesterday I solved this question with suffix hash map. Sorry, suffix hash set. But today I solved this question with bitwise trie. So the main idea is that, I convert each number to bit array and create a bitwise trie from that. And every time I choose a number, I try to find the best body bit array. But when I go through the trie, I notice that I cannot completely create that ideal body. In that case, I make the compromise and go through the node until the reef. The core idea is that I should try to align the most significant digit as much as possible, or I should say higher significant digit as much as possible. So when I compromise, I should compromise in the less significant digit. Yeah, so in that way, I can find the actual best body for each number. So for each number, I get the local maximum XOR for each number, and then in the end, I return the max of them. Okay, that being said, I finished my coding explanation. Thank you so much. Bye.